Hello, Professor and class. I am going to try to breeze through this very quickly to avoid not having too much time spent on it. Um, to begin, we will start with the Pearson correlation. I wish to test the difference between, or the similarities in cortisol or stress and hours of sleep. Does one have an effect on the other? Is there a correlation present? These are the expressed values that I found for the value of x, which is cortisol, and the value of y, which is sleep, and this is, of course, the value of both combined. Uh, to find, to figure out the correlation coefficient, we have to determine the numerator and the denominator in the equation. So the numerator is described as using the total value of x and y multiplied times the number of terms, which in my case is 26, and then subtracting that value from the value of x and y multiplied together, which gives me a value of negative 300 or 3,988. The denominator is the square root of the number of terms times uh, the value of x squared minus the value of x squared multiplied times 26, the number of terms, times the value of y squared minus the value of y squared. And of course, following the square root of all that, we get a final value of 5,000 or 59,000, excuse me, 224 to 0.48. This on the left or on the right here, excuse me, just explains how I went about finding that value without using this long equation, basically breaking it up. And the correlation coefficient is simply dividing the numerator from the denominator, which gives me a value of negative 0.067 or 0.07 if we're rounding up. The correlation coefficient function basically comes to a similar resulting answer. And I will get into what that explains here in a second. The degree of freedoms for this particular data set will be 24. That is the number of terms subtracted by the number of groups, which is 2. Based off of the critical value described in the data set, which is going to be 24 to 0.05, because that is what we are using as a standard, the critical value of 0.388 is greater than the value that we have obtained, which is 0.06. Therefore, we have to accept the null that there is no difference between the level of cortisol and sleep. And based off of the interpretation of all this data, I can determine that there is not a strong correlation present between these two types of data. Moreover, the correlation is that of a -1, as the value that we have obtained is negative. Moving on to our t-test. A t-test would be used, and I wish to use a t-test to explain causes of manufacturing. Is one form of manufacturing better than the other? I'm using battery life of cars. So we have a current method of battery production, and then we have a new method of battery production. I propose that that the new process will be better. That is my hypothesis. Um, going through finding the values, we find the mean and the variance of both groups, and then the total number of turns for each group is n, using the functions described in Excel. The numerator is simply taking the values of both means, subtracting from each other, and the denominator is simply taking the values of the square, or the value of the variances and the number of terms from both groups, and then square rooting them through this long extended function, which you can, for time's sake, I won't go into too much depth, but but this is the full function here. And then our final t is negative 0.5917, 0.59 for 2 decimal places. And then our degree of freedoms is the total number of terms divided by, or subtracted from, the total number of groups, which is again 8, 10 minus 2. Based off of all this information, very quickly, we can determine that our critical value based off of our degree of freedoms is 2.306, described on the table. 8 degrees of freedom 0.05 on the p level. So based off of that information alone, I have to fail to reject the null, so we have to accept the null hypothesis that there is no difference between these production types, as 0.41 is significantly less, or excuse me, there's a mistake in the data, excuse me. We have to, nevertheless, we still have to reject the data that there is this value set is far less than 2.306, so we have to accept the difference there. From the function, it can be determined that there is approximately a 41% likelihood due to chance. This is determined by the ftest function here. Considering that all this data is randomized, this is very likely. Checking time. Okay. Moving on to the ANOVA test. Sorry, there was a bit of a hiccup there. The ANOVA test is used to determine the variance between multiple sets of groups. We are, in this case, determining passing test scores over 3 groups or classes. My hypothesis is that there will be a degree of difference in the classes, so there will be a difference. And to make the data categorical, the scores will be from 1 to 10, with any score of 8 or better being defined as passing. To begin even finding an ANOVA table, we have to find a bunch of initial data. So we have to find the sum of all scores divided by the number of terms, the sum of all sums squared, and then the sum of all individual scores, which is described by this sets of data here, and then of course the value of n, which is 15. There's 15 people in this participating study. We then need to find our between sum squares, or our between sum of squares, our within sum of squares, and our total sum of squares, which is then determined from this equation here. Following this, it is taking the individual from the sum of all scores. Excuse me. The sum of all sums squared from individual scores, and then the sum of all sums from the sum of all scores, and we get these values here, which these are the values that we will be using in our ANOVA table. So moving forward, going into our ANOVA table, we can just simply take these values and put them into here. Our degree of freedom is described up here, so the degree of freedom of the numerator is total number of groups minus 1, which is 2, and then the denominator is the total sample size minus the number of groups, which is 12, which gives us these values for the the mean sum of squares, excuse me, which we then simply, to find our f value, we just divide this value from this value, so the numerator from the denominator, and that gives us a value of 19.47. Moving forward, going off of the F critical value sheet, we take the degree of freedoms for the denominator, which is described on the left, and the degree of freedom for the numerator, which is described on the top. We come to the place where they intersect, go to the value of 0.05. That gives us a critical value of F, or that gives us a critical value of 3.89, which is the minimum value we need to determine if we can reject or accept the null. 19.47 is greater than 3.89, so that not only is it statistically relevant, but we can reject the null hypothesis that there is no difference in passing scores. Going through with an f-test there is no function for an ANOVA, but there is a function for an f-test of between and within groups. So we will be doing an f-test between groups B and C. And we come to the value of 6.6496, which basically means that there is a 64.96% chance that they are significantly different from each other, which can be perceived as
the values of C are in fact all passing, and there's only one passing value in the group of B. But then what does this mean in terms of effect size? Well, effect size is determined from the averages of group B and then the averages of group C divided by the standard deviation of the population, which gives us a absolute value of 2. What this basically means is that comparatively, the values in C are 2 standard deviations of those in class B, thereby exceeding the groups of the scores in those of B by 98%. Um, very, very, very good to know that there is very good to know formula for when you're testing data between multiple groups. And then the last set that we will be doing, checking time, is the chi-square. This is used to determine independency values between two variables. I will be determining marital status and educational level. I determine that there will be an independency factor present between the both of them. Using randomized data, we have married and not married, and then educated and uneducated. And then going through to begin calculating our chi-square, we have to find the ij values for every single one of these values combined. So basically where each of these values intersect. So we have a group for married and educated, married and uneducated, not married and uneducated, and then not married and educated. These are all expressed as expected value by chance. Once we have calculated these values, we will then calculate the actual chi-square, which is taking these values, it'll take these values that we have calculated, the ij values, and then comparing them with the values of the actual group, and then calculating them again. We'll be calculating them against each other, and then like we did for the ij values, we'll be doing that for every single individual value. So, not for the sake of time, I will not go too deep into that because it can be expressed here in the individuals. But the obtained chi-square that we would get from calculating all of this would be the averaged sum of, not average sum, just the regular sum of all these values. So the sum is 28.6. Our degree of freedom is the initial groups. So there's two groups of two variables. So 2 minus 1 for both sets would be 1. So the degree of freedom here is 1. This would give us a critical value of 3.84. Based on all of that data, our obtained chi-square is far greater than 3.84. So we can, based off of these data, we can make a assumption that there's a statistical significance between the two variables and that they are independently different, meaning we can reject the null that there is no difference between the set groups. And that concludes the lab. Thank you so much, and you'll have a wonderful day.